but the majority of evening students are evening students because they're busy during the day. So I will try to, if you want me to come 45 minutes early, I can. If you can get here at 5:30, I'll get here at 5:30 every night and just use 45 minutes prior to class time. If that would come in handy. I can stay after class as well because, well, I have a DVR. So I can watch that stuff later. So curvature, those formulas are given. The formulas for unit and tangent, unit normal, those are not given, so you need to remember how they're calculated. And if you did the homework in section 13.4, you can, the unit tangent vector is a pretty straightforward calculation. It's r prime unitized. You know what I mean? Okay, that's probably, I'm your new teacher now, so I'm using words you've never heard before. When you take a vector and you divide it by its magnitude, and you turn it into a unit vector, I pronounce that as unitizing the vector, so you're shrinking it to a length 1. So both of these are unit vectors. Keep in mind the word unit in their name represents the fact that their magnitudes are 1. Unit tangent vector, unit normal vector, and so forth. So like on a path, something like this, if the orientation of the path was this way, and Beth apparently likes to do sort of, you know, conceptual problems like this, where you're given the orientation of the path and she wants you to sketch what the unit tangent vector and the unit normal vector would look like at that particular point, okay? Well, with the orientation going to the left like this, if you were asked to sketch the unit tangent vector at this point A, or whatever the letter of choice is for naming that point, which direction would the unit tangent vector go? Yeah, to the upper right, because it'll be tangential to this motion and tangent to the curve. So it looks something like this. Now notice there's no scale imposed here. Some of you may say the unit tangent vector is that long. Some of you may go 2 or 3 times longer. But once you set the scale for your answer to the unit tangent vector, that also sets the scale for the length that your unit normal vector should look like. Okay? So if I set that scale for my unit tangent vector here, what would the unit normal vector look like at A? Which direction would it point?
Down to
Yeah. I always pronounce it as the unit normal vector always points into the turn or into the curvature. So since you're curving this way a little bit to the right, if you were driving along this path, you'd be steering your wheel to the right to compensate for the curve. So your unit normal vector would be this direction at that same length. So the unit normal vector should look something like that. Okay? Do the unit normal and unit tangent vectors ever vanish?
If there's no curve.
In other words, if you had no curvature, if you were in a straight line, still oriented to the upper right like this, and here's your point A, what would your unit tangent vector look like? Or would there be one?
It wouldn't be
It
one.
would be straight down the line.
Yeah, there will be one. The unit tangent vector never vanishes.
It's just
So
there.
technically, you have a tangential direction. But what about your unit normal vector? Yeah, but in this case, you have the lamest perpendicular vector of all. The zero vector. A 2-component or a 3-component zero vector. Okay? And technically, this guy is perpendicular to any vector. Because why? If you're dealing with a vector that has all zeros for its components, what's the criteria
There's no direction.
for 2 vectors to be perpendicular?
Dot product 0.
The dot product is 0. And if every component here is 0, you have no chance but to annihilate every other component for the other vector. So technically your unit normal vector goes to 0 when you have no curvature. You can't really draw. You can't really draw into the turn because, well, you're on cruise control at that point. You're not steering your wheel at all. Kind of make sense?
Would 0 be wrong? You'd have to say 0 back.
Well, technically, I'm not sure. Well, I'm grading it. So she made the test out, but I'm going to grade it. So she's completely out of the picture. She's made her contribution. She's now, you know, in getting ready for back surgery mode. That's technically the correct answer, or you could say the 0 vector. If you didn't put the arrow over it, I would probably grimace and frown a little bit, but it's, you know, I wouldn't penalize you. Any indication that the normal vector doesn't exist at that point, or it just goes to 0 at that point. But I believe most of the diagrams that you see on the problems here, like the one that has the big diagram, the rich diagram with all the bells and whistles on it, I think you have curvature involved, so it's just a little tiny nuance. So topic-wise, it's officially 6:18-ish now. So I wanted to spend the first part of class isolating exactly what's on your test, okay? Danielle sent me a list of what she knew to be covered on the test, and I've not listed 13.5 yet, but topic-wise, these are the things that I've seen on the review, and I have seen your test, okay? I'm not teaching from the test, so, just, I don't want to, mislead you there, but I do want to make sure you have all the proper information of what you need to know in preparation for the test. So, I'm pretty sure 13.3 can be kicked under the bus, because the main topics there are arc length and parameterization with speed and things like that, and I didn't see it on the review, and I want to let you know I have not seen it on the test. So you can strike out 13.3 from your list of things to look at, just because it has no presence anywhere, and the stuff that I've seen I received from Beth. And going down the list, your test begins with 13.1 and ends with 14.3 from what I've seen. There's one thing I need to delete from the test because it technically comes from 14.4. Some of the stuff she was kind of going into last Tuesday night with the differentials, and she was about to start talking about tangent planes. There was a tangent plane problem on the test. It has been nixed, so don't worry about that. Your test is going to come from those, 6 sections, okay? 13.1 is pretty much just about plotting a vector curve, and she alludes to on her review, plotting vector curves, things like circles or ellipses, and being able to say, well, at t equals, pi, or at t equals 1/2, draw the position vector. And so, in that instance, everyone feel free to take a picture of this if you want to. I will post this information on D2L, but while I'm thinking of it, before I completely brain fart, I went ahead and made a new calendar for you to kind of give you some inkling of what's going to be covered for the rest of the semester. And keep in mind, I was sort of faced with the task of taking 2/3 of this course's content and wedging it into 6 weeks. But I wanted to make it as digestible as possible. So there are some things that you'll see on here that have been unfortunately omitted from what Beth originally intended to be and what I would usually have in a Calculus 3 course content. But I've gone over and kind of filtered out the stuff that is the major things you need to know from the remaining chapters. So let me hand this out. And one thing I failed to do on this is to write this information. So when you get this piece of paper, if you'd like to jot down my information, or you may already have it in your notebook, but this is just a handy little calendar to hopefully get us through the rest of the semester without any further weather delays from Elsa or anybody else who wants to freeze Knoxville. Victor Freeze, Captain Cold. All right, there you go. Oh, and the other, I guess, calming fear that some of you may have, is there anyone in here who cannot possibly take a test in the testing center?
Well, it's open on Saturdays, right?
It's open on Saturdays. They open at like 8 until 1. And I want you to all have at least 2 hours for the test. So, let me pull up the testing center's calendar so that way you can kind of double check it and cross-reference it with your schedule. I want to put test 2 in the testing center beginning tomorrow. Show of hands who would be ambitious enough to take it tomorrow. Yeah, that's what I thought. Okay, so thank you for the extra day in making the test edits and making the copies and stuff. The testing center's schedule looks something like this. Some of you may have it committed to memory. But, let's see, academic students testing center. Here we go. Let me toggle this back out. Testing center hours for spring. Harding Valley campus. Okay. So, the times I want to put it in the testing center is beginning tomorrow. Yeah, right. And leaving it in there through Monday. Okay?
Thank you.
Are you... Okay, I've got a few names, but you're the one who...
Matthew Swearingen, yes.
You're Matthew. Okay. And leave it in there through Monday because, because I figured nobody take it tomorrow. But leaving it in there through Monday. You're really taking 26 hours
yes,
this
sir.
semester.
More than anyone on
Here
any campus.
and where else?
Just here.
How'd they let you?
I've taken 19, 21, 23, 22, and my GPA is 395.
You're
they
awesome.
let me take
You're
26.
bulletproof, so.
Well, thank you very much, sir.
And these, I'm
gonna try
gonna
to
tell them what you're
pull this
taking,
back.
because I was friggin' impressed.
Oh, you took a look at it?
Yeah, well,
Okay.
no, you told me.
Oh,
You
yeah?
told me some of the stuff you're taking organic,
Yeah, I've got organic
Which-
2, AMP 2,
Chinese.
Chinese 4,
like Mandarin.
biology, yes sir, biology 2, sign language 2,
And you said
physics
physics.
2,
Yeah.
and then Calc3.
A
Are
and
you
P,
majoring and everything?
Pretty much, yeah.
pre-med,
Yes, I'm gonna be a biochemist, a trauma surgeon, and then law school.
they'll make TV shows about you probably.
Astrophysics.
All right, so kudos, how did you get them to do that? They just,
Dr. Kelly originally approved my first over maximum hours, and then they just kind of let me do it ever since.
okay,
Yeah,
well,
thank you
no
very
worse
much.
for the wear, so. All right, so is there anyone in here looking at the schedule, beginning tomorrow, yeah, right, Friday, Saturday, and Monday, who would not possibly be able to go to the testing center at some point for a 2-hour window and take the test? Because the only option I can imagine is maybe me coming here later in the afternoon on Saturday and finding a classroom to give it for 2 hours then. Everybody pretty sure there's a time slot you could commit to for 2 consecutive hours? Okay. All right. So the testing center is okay. If you double check the calendar I just gave you, I want to do that for test 3 as well. So do you think you'd still be able to, halfway between now and end of the semester, do that? Okay. Do that again. Okay. Did Beth, and I looked at your policy sheet, but I'm not really sure if this has been verbalized to you. Did Beth have an intention of giving you a comprehensive final exam?
No, she said that she wasn't going to.
Okay.
I think in the beginning, before we lost the 2 weeks,
Yeah.
she had the idea of doing the comprehensive, but then when we lost the 2 weeks, she talked about just doing that as like the last.
That's good, because that's what I have committed to with this calendar. If you double check the final exam week, which on the calendar it's actually Tuesday, well the date's not missing. Oh yeah, it's May the 5th, Tuesday, May the 5th. During the time slot for our final exam is 6:30 to 8:20. So you can begin at 6:15 just like any class night if you want to and have 2 hours for that. And that'll be test 4. It will not be a comprehensive final. So did she have any kind of policy in place about replacing a lowest test grade?
I was just about to ask you that.
And I'm asking
It
you
was
because-
originally going to be the
That was-
final,
Yeah.
but then with the snowstorm,
So currently, without a final, there is no way to replace your lowest test grade.
What she did was, she said that she doesn't like the 7-point scale, 93 to 100 say.
Mhm.
She prefers a 90 to 100.
Okay.
And so she kind of shifts everything to where if you get a 90, she
It's-
will shift that to like a 93.
Okay. So 90 and up is A,
Yeah.
80 to 90. or 80
and then 80 to 90 or 89 is B. Okay. Okay. I'll just double check, make sure, because I'm not saying that but y'all really could take advantage of me like crazy right now.
Right. Or if you
But,
just want to make our highest test grade, replace our lowest test
Well,
grade.
see, what I've done in the past is
Yeah,
give
drop
the
the lowest
students the
test
chance to
grade.
retake a test.
2 tests.
If
Wow.
I've,
Oh, that's. Man. Everybody gets
I'm not committing to that.
No,
I'm not
doing
committing to
it.
that.
What's
But
it
I've
doing?
done that in the past. I have no control over your test 1.
Mhm.
So that means, if we do this as a means of replacing a test grade instead of taking the final exam, we could do it for test 2 and 3. No way to do it for test 4 either, because it's on final exams week. So really, if you did want to try to retake a test, the options could be for test 2 or for test 3. I have no control over your test 1 grade. Unfortunately, I have to say, I guess it's etched in stone. Okay? Was test 1 that bad? Okay, well, okay, that's a completely open-ended question that none of you should answer unless you know you did really well on test 1. So that's an unfair question for me to ask.
I didn't know what I was doing. I kind of just rationalized my way through it.
Okay,
I haven't worked in any of this before,
okay.
and I didn't know
Well,
that there was.
all of you are
a
kind of
study
taking this for
going
the
on.
first time, so it's your first bout with Calculus 3. Hopefully your only bout you'll lead with Calculus 3.
Oh,
So testing center's okay for test 2 and test 3. That's what I wanted to double check. So now the immediate need, your test. So going back to my list here, okay? These are the topics I have seen and will guarantee that you see on test 2 from section 13.1. And if you all got a copy of the review in front of you. Section 13.1 was all about just plotting vector functions and understanding the defining properties of vector functions. Like she kind of mentions on the review itself, and this is sort of the topical part of the review. Trace a path given by R when the path lies along well-recognized graphs such as circles, ellipses, parabolas, straight lines, etc. So be able to graph a vector function and just plot a few points and then connect it with a curve, and then she'll probably say plot R of 2. And so if you have a vector function plotted out, do y'all have this off chance? Okay. So if you plot out a vector function, we keep the good one. Oh, I forgot to set an alarm. I usually set an alarm that represents the end of class, and usually on a 2-hour class, I let out 10 minutes early in lieu of taking a break halfway through, because the 10-minute break halfway through always turns into a 25-minute break for a handful of people. So I usually, on 6:15 to 8:15 schedule, I usually let class out at 8:05. Okay? So plotting a vector function, something like an ellipse or something like that. One thing that's essential when you're plotting one is to make sure you list the orientation of the curve. Like if it's counterclockwise or clockwise, something like that. And then, you have the origin here in the middle. She may ask you to plot R of, well, let me put an actual equation with this. Let's say R of t here, something that would look something like this would be maybe 5 cosine t and then 3 sine t. Do you know how to graph these on your calculator? I know she's not much of a calculator proponent, but you can graph these using the parametric mode on your calculator. Have you used the parametric mode on your calculator? So, okay, then you will need it for the test, okay? But, so essentially, just plot a few points, like maybe t equals 0 will produce the vector 5 times 1, 3 times 0, so this is the actual vector you get for R of 0, okay? And then when you go to, the next, I guess, easiest value of t to use would be, what's R at pi over 2 look like? Well, if you plug pi over 2 into cosine, it goes away to 0. If you plug pi over 2 into sine, it goes to 1. So this becomes 5 times 0, an I component of 0, and then comma 3 times 1. Is this notation foreign to you? Using the little V-shaped brackets instead of I's and J. Okay, so that's good. And I'm sorry, if I keep asking questions like that, it's just because I don't know what kind of notations and things Beth has used heretofore. So 5 times 0, 3 times 1. So this specific position vector would be tailed at the origin and just locate that point on the curve. And she probably wants you to graph something like this. She may ask you to do R prime at pi over 2. Okay, well, can you eyeball something you know that has to be true about R prime at pi over 2? Just based on the ellipse and the orientation of the curve of the path.
I was thinking tangential.
It is tangential. And what's kind of handy about something tangential right here? It's going to be horizontal. Will it have a positive or a negative component? Negative, because it's pointing left. So it should be pointing in this direction. The only thing we, I guess really can't determine until we do the derivative is the magnitude of the vector, okay? So it should be going in that direction because that's the orientation of the curve. And so if I actually did R prime in terms of t, that will give me negative 5 sine t and then positive 3 cosine t. Just doing your derivative one component at a time, okay? And then if I plug pi over 2 into this, remember at pi over 2, sine goes to 1, cosine goes to 0. So this becomes the vector negative 5 for I, and then 0 for j. So we have the right direction, right orientation too. And it should have only an I component. So it should be exactly this long. Because those x-intercepts are at plus and minus 5, so that would have to be a vector that's the same length right there, negative 5i. Okay? So that's some of the things that you could probably kind of depend on from, graphing vector functions. And that's kind of a little bit of an overlap with 13.2 as well. You didn't get to any calculus on vector functions until you got to 13.2, when you were actually doing R primes and also the problems where you're given acceleration and you integrate it backwards with the initial conditions to find velocity and find position. Okay, those are the typical things you can kind of see from 13.1 and 13.2. And it also popped up in the graphic problem. Oh, hello, I'm on here now. The one where you're given, oh, one quick edit I want to make sure you're aware of. On number 3 down here, this topical review says, given a vector function r, you should be able to find the equation of the tangent line. Make sure you're aware that you'll be prompted to find the parametric equations of the tangent line. Okay, so you'll be expected to give your tangent line in parametric form. That's a darn good hint as to a particular test problem, because I want to make sure you saw that wording. But of all the other vector function kind of problems, this is I guess the main thing I'm thinking of, this first problem on the review, where she gives you just a generic vector function's path and its orientation, and she asks for specific things at different points. Okay? Have you had a chance to do the review? Because I was hoping you could have done the review by tonight, maybe, and sort of had some questions. So you have the vector function drawn out here. The orientation according to this arrow is right-ish to left-ish. And there you go, at the point C, draw what r of t would look like with its tail starting, no, correction, what r prime of t would look like with its head starting at r of t, not. So at the point C, she's drawn the r vector for you right here. She just wants you to go back and draw what r prime would look like. So r vectors are always tailed at the origin. Our prime vectors will be tailed at that point on the curve and be drawn tangentially. Okay, so you know your answer to part A there would just be a tangent vector that kind of goes this way. And again, the magnitude's relative. I can only check tangentialness. So some of you may say r prime's this long. Some of you may say r prime's this long. As long as it's going this way, and as long as it appears to be tangent roughly as best as you can eyeball, freehand, to the curve at C, that's fine. Again, normal and tangential, or unit normal and unit tangent vectors at a specific point. Remember, you got to eyeball the curvature there. The unit tangent is going to be in the same direction as your motion. The unit normal will be into the direction of the turn. Okay. Components of acceleration at point P, right here. It says the tangential component of acceleration is -2. The normal component of acceleration is 3. What would the acceleration vector look like in that case? So at the point P, let me give myself, is it bad for me to raise this camera-wise, Danielle? No glare? You're okay? All right. So I know my orientation is this way. You're dealing with the tangential and normal components of acceleration. Well, the tangential and normal component for anything is going to be in the same direction as the unit tangent vector, which would be roughly that way, and the unit normal vector, which would roughly be that way. Okay. I'm using dotted lines to kind of get my frame of reference right, okay? That is the tangential direction because that's the orientation of the curve and that's into the direction of the curvature, so that's the correct positioning for T and N. Your tangential component for acceleration was given as -2. The normal was given as 3. So how do I use this information for me to draw that?
Find the magnitude.
And that's what those numbers kind of represent. Magnitudes are almost always positive values, but whenever you see a negative ascribed to them, that just means it's going to go in the opposite direction. So if I have a tangential component of acceleration is -2, and let's say I set this standard right here as unit length. Those little dotted lines represent unit vectors, so that means 1. So a -2 tangential acceleration component would be, let's see, 1, 2, about like this. A sub t, okay? The normal component of acceleration was given as 3, +3, in the positive direction of the unit normal vector. So 1, 2, 3, about right there. That's what A sub n would look like, okay? You're asked to use this information to sketch what the acceleration vector would look like at that point. How do you get A from A sub t and A sub n?
Just add them.
Yeah, just add them with the parallelogram law or the tip to tail law, whichever law you do for using vectors. These are perpendicular vectors, so it's an easy parallelogram to draw. So the resultant of that normal and that tangential would give you an acceleration vector that looks something like this. Okay? And then she could, you know, kind of say, does it appear that the object is speeding up or slowing down in that case? Slowing down why?
Because your tangent acceleration is in the opposite direction of your curve.
Yeah, a negative tangential kind of indicates that you're probably going to be slowing down too. If you're, if the unit normal vector, or if the normal component is longer than the tangential component, that means the curvature or the spin is causing a bigger influence on your acceleration than the speed. Tangent direction is always going to be in the same direction as your velocity, and you know normal is going to be into the curvature. When this is longer than that, the curvature is a bigger influence on acceleration. It usually means, it can mean you're speeding up, but because it's going kind of against the flow of the motion of the particle, that would indicate to me that it's slowing down there. Okay. Yes, sir.
The normal vector can never be negative, correct?
Then I don't believe it can, because I was thinking about that. Your tangent can, because you can be slowing down speed-wise, and a sub t kind of ties in with the velocity, but your normal component, or your normal component should always be pointing into the direction of the curvature, because acceleration is a vector quantity. Vectors are influenced by magnitude and direction. So since acceleration is the rate of change of your velocity, speed can influence acceleration. The rate of change of your speed can, and that comes from the a sub t part. The change in direction comes from how fast your normal vector is sort of moving as you turn, okay? And so that's the influence of the normal vector on the acceleration, okay? But it should always be pointing into the curvature, so the end part should never be negative. Yes, sir?
When you said that your normal vector, if it was larger than your tangential vector, that you indicated that meant slowing down.
No, doesn't necessarily mean slowing down, because you can still have a unit tangent vector that's this long, a unit normal that's that long, or a tangential component this long and a normal component that long, and that still means the curvature is a bigger influence on your acceleration than your speed.
So your curve is getting sharper.
Yes.
Okay.
When n gets longer, you're in a tighter turn. Mm-hmm.
Okay.
Well, when your a sub n gets longer, excuse me, your n never gets longer.
Right.
It's always unit 1. Yeah. Okay. Let's see. Some other things asked about this. Okay, at point P. No. No, a different set of points. Points R, W, and S down here at the bottom. It says, if the object maintains a constant speed as it moves from R to S, so from R through W, then to S, if it maintains a constant speed on that little arc, what would the acceleration vector look like at the point W?
Completely tangent.
Pardon?
Completely tangent.
Would it be the zero vector?
No, it should be normal. Yeah, because if you maintain a constant speed here, going, orienting around the curve that way, or, in that direction. So the tangential component doesn't play as big an influence as the normal component. The normal component is really going to be your main acceleration. But if you have constant velocity, what is your acceleration going to be?
Zero.
It's going to be zero. It's going to be zero influence from the speed. But you're still changing direction. So the only contribution to your acceleration is in the normal direction, the curvature itself. So that's what your acceleration vector should look like. And if you're in a circular path, how do you remember that from physics? If you're dealing with circular motion, what's the direction of acceleration from a circular path?
Acceleration.
Centripetal. Center seeking, right? Not center fleeing. Yeah. So it's toward the center. Yeah, into the center of the current. You don't need to know that if you haven't had physics yet, but you'll kind of apply that to physics when you get there. Which is why I'm a big proponent of having this class before you take anything E&S, although that would really delay a lot of folks. Waiting to Calc3 to do that. Let's see. Okay, here's a good question. Focuses on this point B over here on your left. So let me move this and erase my imagery I've got up here. Okay, at the point B, you see there are 4 vectors kind of stemming away from that point. Because it's part of a multiple choice problem. Okay? She says at the point B, okay, or between the points A and M, between going from A to M, and that's a little bit annoying, isn't it? Going from A to M, the velocity function is this, 13 minus 41t. It's this problem I'm reading right here. Okay, and that's a scalar function. So in other words, it's really just telling you your speed. Okay, well, not really your speed. It does have signs to it. So you should sort of consider the positive and negativeness of your answers to influence your answer down here. Okay, so as you go from A around to M, that's your velocity function. Which of the 4 vectors drawn in part B could possibly represent the acceleration of the object at that point? Of the 4 vectors you see there, there's 4 coming away from the point B. So if this is the velocity function, which of those 4 could possibly represent your acceleration vector? Notice it doesn't say a sub t or a sub n, your acceleration vector itself.
Since it's got the minus 14, would it be going in the opposite direction of the
Yeah.
curve?
If you look at this as the first derivative giving you acceleration, well, I should just say that. Negative 41, you have constant acceleration going through from A to M. So if you have a negative acceleration, you should be slowing down. So that narrows it down to these 2. Should be going against the orientation of the curve, the direction of the motion. Okay, so there's a 50-50 chance now as opposed to a 1 in 4 chance. Of these 2, which one could possibly be your the top one versus the bottom one? Why?
Because it would be within
Points
the
on the
unit
curve.
tangential and the unit
Because of the
normal.
curvature, yes. At this point, your normal component will be pointing this way, and apparently, according to this, your tangential component, your unit tangent vector, will be going this way. But the tangential component of acceleration would most likely be negative. And then you have a normal component of acceleration going this way. So if I have I've got an acceleration vector at that point, it should be the resultant of something that has those 2 components for tangential and normal to acceleration. And that's the only candidate that could have that as a resultant of those 2. So it has to be this sort of almost northeast bound vector right there. Okay? But in the moment, in the intensity of test time, 2-hour time limit, oh my gosh, would you recall that? Would you be able to hash that out, reason that out? She likes the conceptual problems. She likes the problems that sort of make you dig a little bit deeper and just, test your familiarity with this. Okay? All right. So let's see. The only representation of curvature I saw on any part of the review, well, she alludes to needing the formulas. Let's see. Well, these are the computational problems. Let's see. She alludes to the curvature. Here, compute the curvature for a curve. I'll provide the formulas, but not specify which to use. So you are given both versions, the version that does the cross product magnitude with an R vector and an R prime and R double prime, and you're also given one for a scalar function f. So depending on the way it's given on the test, you want to make sure you use the right formula. So you could have just a straightforward curvature calculation problem on there. But then, give the curvature of a circle of radius r. Did she go too terribly far into detail about the curvature of a circle?